let's get going. So, I'm going to talk a bit about Saltstack. So if the first talk was about more like IDs and how you do stuff, this is going to be a more technical one, specific on one tool, basically. So how many here has run Salt or are running Salt today? And how many are running Ansible? It's going to be quite a fight. How about Puppet? Chef? Yeah, it seems to be kind of a thing in at least Stockholm that most people are running either Ansible or Puppet. And kind of Chef and Saltstack is kind of on their own side. So I'm going to talk exclusively about Saltstack, and I'm going to talk about event-driven infrastructure, which is really what I think is the most powerful part of Saltstack. So for you that doesn't know, Saltstack is a configuration management tool. It's built around remote execution. So you do something, you tell your minions to be in one kind of state, and you do that at the time of your choosing. It's also a cloud provisioner, so you can provision cloud, you can provision bare metal, you can provision almost any of the providers out there. And it's also very useful for doing more tooling around orchestration. So a lot of guys were talking about setting up actually the whole environment of your system on one machine or on many machine production using the same kind of tool. Benefits that I see with Salt, it's of course discussable, but it's very fast. And it's fast because it's utilizing events, basically. It has event bus, so it has event bus on the master and the minion, or on the minion if you run it masterless. And it's actually sending these events back and forth. So everything you do is an event within Salt, and it's reacting to those events. That kind of methodology or design is also what makes it really reliable. So it's actually that master can be down and the minion can take care of itself on its own event bus. I'm going to be talking a bit more about that later. It's built using Python, so if you're familiar, you can run your own stuff and add your own modules and etc. So I'm going to talk about little things now. Probably going to be quite a short talk, and then a demo at the end. Hope everything works. I can start a bit about what we're utilizing Salt for at Bloglovin, and talk about Bloglovin, where I work, where I do all this kind of fun stuff. So Bloglovin is a RSS reader platform utilized for people that doesn't know what RSS is or doesn't know anything technical at all. They just want good content, and they want the newest content from all their blogs that they follow, or blogs that they think they want to follow when we recommend them to them. So we have a couple of million unique monthly users. We have a lot of requests each day. We're server-based here in Stockholm, but we're also utilizing cloud a lot. So this kind of brings us into why we choose Salt in the first place. So a year ago, we didn't have any automation at all, so everything was done manually on our bare metal servers. So apt-get whatever you wanted. All the servers were looking differently, even though they were supposed to be a web server. So we needed a tool that we could use on both our bare metal servers and one which we could use for our cloud stuff and for our development process and the whole CI pipeline. Right now we're running around 90 Salt minions. So a Salt minion is a server that you control, and 2 Salt master which are synced, should be synced. Yeah, so within Salt we are using most of the things. There are really, so Salt is very flexible. You can do a lot of things. You can do small, easy things. You can do complex things. But the kind of key component to Salt is try to keep it simple. And there are a lot of terminology around Salt, like they have a lot of words for everything, like there is for all kind of configuration tools out there. So we're using the state and the pillar and the grains. I'm gonna walk through this quite fast, just so you kind of get like, what is that and how does it work, how could that apply to me. They have something called Orchestrate, where you can actually orchestrate a whole process. So let's say you want to build up that dev environment for that developer. Of course, you can do it with Packer and Vagrant and that kind of stuff, but you could also do it with Salt, and I think that scales better. We can have a discussion afterwards. They also have something which I think is the most powerful part of Salt, is the Reactor. So since Salt is based upon events, which happens on the different event buses, you can actually react to those events and do stuff depending on what kind of states or what's happening on the minions and on the master. And then I'm going to talk just tiny about the Salt API and the Salt Cloud. So let's start about the terminology first. So the basic stuff is that Salt uses a master minion workflow. That's kind of the basis. You can run Salt masterless. A lot of companies doing that, if the user case is old, it's usually when you want to do auto-scaling on AWS, you don't want all the new servers to actually connect up to a master and have that master as kind of a central point of failure. You want to take that out of the equation. And then at that case, you would probably go masterless. We're running master minion setup, so that we can benefit from the Reactor and the kind of event stuff that I'm going to be showing later. The different parts is state, modules, and grains and pillars. I'm going to walk on through this. They are quite similar in a lot of configuration management. They just have different names, as I said. On the transporting stuff, it's using 0MQ as the event bus. I'm going to talk a bit about that also. You can also use SSH, like Ansible is defaulting to. So you can actually just have your repo locally and do everything over SSH. Works fine, it's slow and painful. So, execution. This is basically what you do with Salt. You tell Salt to target, can be a group of minions, can be all your minions, can be just one minion. And you want that minion to run a function, and you want something to happen. And the most important part is probably this one, which is actually called you run a module. And there are modules for doing anything. Modules is basically a Python script which executes stuff on your minion. There are modules which you get for free. Everything is free, of course, it's open source. But you kind of get that within the Salt community for everything that you can imagine, basically. For networking, for connecting to PagerDuty, to Docker, Nginx, Varnish, all the things you need. So an execution module, when you run it, could look something like this. So here I'm talking to a network module. I'm querying it for the interface, and I'm getting back data representation of that information. And it's fairly simple. And we're going to come back, I'm going to be using this example later as well. There is also a module which is Frighten, and you can do a lot of strange things with. It's called CMD Run. CMD Run is basically, you can write anything that you want to write within these parameters. So you can basically do anything on the system. Very useful if you want to tail through a lot of log files, so you want to see folders on a lot of minions at the same time, if the state has changed anything. So here I'm doing exactly the same thing I did before, but here I'm doing it the bad way. But this is usually the way that people start using Salt with, and then they recognize all the modules itself. This is great. Now I can remote execute something on all my minions at the same time. I can install a patch on all my web servers, or I can configure my SQL, etc. But I have to type everything in. And that's quite boring. So Instead, Salt uses something called states. State is basically a file where you define what kind of state you want the minion to be in, or you want that specific thing to be in that state. Basically, super easy. It uses the same kind of modules you use on a command line. So, for example, this state. If we have this states on the, if we would run this state on a command line, it would be something like this. So you can always do both things because they are using the same module. That's kind of the important part. But this is kind of easy state. I would probably do something a bit complex. You probably want to modify the config file. You probably want to allow certain sets of IP that can connect it, etc. I'm just gonna rush through this so we can have the demo later. But if you have any questions, just raise your hand or we can talk afterwards. Then we have another part of the Salt system. It's called Grains. Grains is usually it's a system that Salt can query for additional information about the minions. Usually stuff that happens, or there are more long term. So the CPU of a server, the server operating system, all this kind of information that you want sometimes, and that you then can use in states or when you do remote execution. So in this one, I'm doing the same thing here. The important part here to know from how I did it before with the module is that this one is probably cached in a lot of places. So this will be the information given to the minion on creation. And when I use a module, I will get the current state, where it will actually execute that on the minion. So that's good. We have information about our minions, and then we also want to be able to store secrets. It's always an issue everywhere. You always have a system where you have secrets, and you don't want all of your servers to have all the secrets. You want to kind of select which servers should get which secrets, and that's you do with Pillar in Salt. It's kind of the same system. You can use Pillar in a state file, or you can use pillars and set pillars within when you actually do something on the server. So cool. We've kind of been through this. You apply a state to the target, and when you have your state files, you have different state files for different things. You have your pillars, which you uses in your state files, and then you put your minions at a HighState. And a HighState is basically this is how you're going to look. This is how I want all my minions to look, and they can be defined differently. So we have the MySQL servers; they get this configuration, and the web servers get this configuration, etc. You can always apply that in a HighState. You can also, as Public Chef works, that they kind of run on a schedule, so you can run this HighState on a schedule if you want, or you can run individual state on different time schedules, which can be really useful for updating certain stuff. Cool. So that's kind of the basic with Salt. I'm now going to go into the more fun stuff with the event and how you can kind of work with those. Bring it on.
Pillar, is that available if you run Elastx?
Yes, you can actually, but then kind of the whole idea with Pillar gets kind of not that good, since you can do that. You populate a file on that minion which has those pillars, but then you can usually use grains as well. So Pillar and grains can be stored in a file, it can be stored in an external database, or any other way. Yes. So the event system, as I said, it's a message bus basically. You throw a event at it, and you can read events. And every event has a tag, so you can check for that tag and react to it. So here's what you get if you listen to the event bus on the master while you run a command. So we're running the command test ping that will basically just go to the minion, and the minion says, yeah, I'm up, I'm responding. So what Salt does when I write that command on the command line is it triggers a new job, it assigns ID, it says that I want this to be run on this minion, and which user, etc. And then after a while, I will get an event back from the minion telling that this ID returned true and successful. It's quite easy, or it's quite small here. If you have bigger events where you actually update a version of an application, you will get back all that information on the event bus as well, so you can query it for stuff. And this is nice. We can see the events, we can kind of apply state and then get an event back. But the most interesting part is the reactor. So the reactor sits on the master, and it reads all these events that are coming in, and it looks at all the tags, and it can trigger action based on which tags are coming back. And what it does is that when it finds a tag which it will react to, it will actually run a state file. So this is how it looks when our reactor gets a call from our Jenkins that our application containers has been built and should go out in production. Basically getting a lot of information from our Jenkins slave, which is also a Salt minion. Yeah, you know, those overlaps in the last part. Everyone is using all the tools together. We get a couple of things, or a couple of data in, and then we run a state SLS file, so a state file. We target specific nodes, which we get from our Jenkins server, kind of where do we want to deploy all this shit. Tells which application we should deploy and which Docker tag we should deploy. And the reactor will take care of it and then report back, etc. And this is super great if everything is in your Salt cluster. But if you want to interact from the outside onto your Salt environment, you can do that as well. Salt is providing a Salt API. So it's basically just a REST API. You can do everything that you can from the command line. So here I'm doing a test ping, exactly what we did before, and it's targeting all the minions. Of course, you have to authenticate yourself, etc. But there is also another smart part they have built into the API, is that you can utilize webhooks. So webhooks is usually just something that says, do this, and it will just return true, and then something else will fire off. This is something that we utilize when we start up development boxes. So the developer itself will run a script on their computer, will fire off a call to our Salt master. Our Salt master will, via the Salt cloud, build up an AWS instance or any other provider out there, and they will get a dev environment by just calling the Salt API once. So you can react to stuff that happens in the reactor, and you can apply state files, and that's quite sweet and all, but Salt is actually can do all the other stuff as well. So we have our production environment, we have our staging environments, etc. We have states on all of those different servers, different configurations from the state files. But then, let's say we want to start a new environment. You want to start a database, which you probably want to populate with data, and you probably want to touch the DNS at the same time to route traffic, probably change the load balancer, and you want to do that in individual runs. You want to do that all by itself, but it should also check if the other things are already happened. That's where the Salt Orchestrate runners are coming into the picture. So a runner is something that you can take. Not really sure how I should explain this, but it's basically forking off the process and doing stuff on its own and then reporting back, basically. So it is an orchestrate runner, which can apply different states within itself. So it can start with, I'm going to just show you. So this is kind of a cutoff of when we start AWS instances. So let's say we want to start instance first. We want to do that. We don't want to start the next state until that is finished. So we require that the salt create instance needs to be run before the HighState. And here you can put in as many things as you like populating a DNS or seeding a database, basically whatever you want to do. And maybe also upgrading salt at the same time when you do it. Cool. Any questions so far? Cool. We're going to go into the last part. And that is something new that came a couple of weeks ago. It's called beacons. And so the Reactor and the Orchestrator, it's usually always happening on the master or on the master minion when you're running masterless. So the beacons are things that can send back events on the minions themselves. So if something changed on a minion, you want that minion to report back to the master. This has changed, and then the master or the Reactor can react to that, then put it in different states or change different stuff or report to someone else. So if the disk space is running out in the middle of the night, you just don't want the Nautilus to call you up or get a PagerDuty call. You actually want it to fix itself. Because we all hate waking up in the middle of the night. And we do that too often. Yeah, so I'm going to do a bit of a demo here. Hope this is working. So you're hopefully seeing that. So I have a just test master in a minion. It's actually, let's see, it's actually 2 minions since the master is running a minion on itself as well. And on this master, I'm listening into the event bus. And yeah, these are the ones we saw before. It's basically an event coming in on the event bus. So if I do something like this, it triggers events back and forth quite easily, like that. Let's see. So here I have my minion. Should probably split this up so you see it at the same time. Cool. So everybody's seeing that, right? That. So right now I have a beacon that is checking services on the minion system. So it will check if Nginx is running or is stopped. Very simple beacon. You can apply it to any service that you run on the system. The only thing it does is that it does service application status and reports that back to the master so that you can react to it if it changes. So I stopped Nginx, and at the master we now know that Nginx is stopped and can react to that. And we can start it again, and it will get a trigger that it started. You can do the same thing with the disk space. There aren't that many beacons right now, but you can write your own.
Didn't you say that the beacon actually does a service status?
Yeah,
But
all the time.
Okay, so it is actually basically polling the status of the service.
Exactly.
And it's just doing it
so
quickly.
So it's actually doing it here. So this is on the minion itself.
Okay.
So So yeah, for this specific beacon, it's doing that instead of something nicer, but probably, hopefully it doesn't take that much of power from it.
Okay.
Cool, so I'm gonna show, so this is quite nice because you can actually react to it. So we could always make sure that specific services are running instead of having another application running on that system. So this kind of thing that I always strive for is to have as few components as possible, and if I can do it all with Salt, I'm super happy. So I'm gonna do another thing here. Yeah. So we have another beacon running. I hope it's working. It's checking if somebody logs into the box unauthorized. And it should trigger an event and trigger up on that event. So now we only saw that actual event, but we want to see kind of what the reactor is doing and how it triggers on that event. So let's see. Hold on. So yeah, we should be there, and we're logging in as admin. And resolve. And permission denied. Oh no! It's not working.
You should have prayed harder.
Well, the first kind of didn't work, then the second one always kind of flips around.
So should we have some commercial now, or?
Yeah, this is usually what happens. Oh, there it came. A wonder.
Second time.
Always works the second time. So basically what happens now was that it got listens on a log file. It takes the content of that log file, since the system anyway logging that is an unauthorized access attempt. It listens on that log file, put it out on the event bus, and then we do something about it as well. So this part is actually the first incoming one. We'll actually get that event. And then it will see that, okay, there's a new event, I have to do something about it, and it will trigger off a state. Let's see if we have, no. And this specific event is a state that is sending a message into our Slack channel. So if I go in here, I see that, yeah, the bot has posted in our Slack channel that someone tried to log in. Fairly simple setup, and as you all kind of noticed, it's just your imagination that is stopping by when you're dealing with events.
Do you see much of that in production?
Hmm?
Do you see much of that in production?
Events or?
I mean alarms basically from Saltstack.
No, not yet. We do a lot of like trigger, like to tell us stuff or send email and those kind of stuff. But we haven't started using beacons in production yet, since we are on not the latest stable version of Salt in production. So let's see. Yeah, so that was the demo.
Do you plan to replace monitoring with beacons?
Definitely.
Yeah.
Yeah. So there is actually a beacon for the load kind of stuff as well. So,
Yeah.
so Salt has actually had that for quite a while. You can query the machines for load and those kind of stuff. But there will be a master querying the minion, and now you can actually do minions sending stuff back to the master.
Yeah.
And it's actually the master doesn't need to be up. It will set it on the event bus, and when the master comes up, it will collect all those events, which is a nice feature. So yeah, we are definitely looking forward to experimenting more with this.
Yeah. So the master is constantly pulling the minions also to check
Yeah.
that they are alive.
Exactly. Or I'm not really sure. You can specify that how that transaction should be between the event bus itself. Any other questions or?
You mentioned in the beginning there that you do bare metal provisioning with Salt as well.
We actually don't do bare metal provisioning right now. You can do it.
Okay.
We-
What it supports? Well, you can manage PC boots and stuff
Yeah,
like that as
PC
well.
boots.
EPMI.
Yeah, that's the only thing that I've looked into it as well.
Yeah.
Any other? So, if there isn't any other question, I would like to all thank you. And also, there is a Salt meetup.
Could maybe do just a short shameless plug on that.
Do it.
Yeah, so I'm the organizer of the Saltstack Stockholm Meetup, and there's a meetup coming up on the 9th of June, which will focus on the Salt Cloud provisioning modular part of Salt. That's about it.
Yeah, look it up.
Cool.
Cool. And if anybody wants to talk Saltstack, I'm going to be here. Thanks.